Hello, human geographers. We are back at it again this evening. Tonight, we begin our discussion of industrialization. Now, recall that earlier this year we discussed the events of the Industrial Revolution. So let's start with a quick recap. The Industrial Revolution was a series of improvements in industrial technology that transformed the process of manufacturing goods. And the Industrial Revolution began in rural areas because there was an abundance of coal, which combined with new inventions like the steam engine, created an environment where industrialization could occur. Now, once the steam engine was applied to weaving machines, factories moved to urban areas where most consumers were located, but also where there was an abundance of labor. But how do we get the coal, which is heavy, to those urban factories? And that is when the steam engine was applied to transport systems and the steam-powered locomotive was invented. This necessitated new materials to build tracks for railroads. Fortunately, with the abundance of coal, which burned hotter and longer than wood, combined with iron ore, produced a newer, stronger metal, steel. So why did the events of the Industrial Revolution unfold as they did? Why did it begin in the rural countryside? Why did it shift later to urban areas? Well, there's a quote from a famous geographer that said, "The combination of energy sources and technology greatly impacts the times and place of industrialization." So broadly speaking, technology plus energy equals industrialization, or at least they are the factors for industrialization. So to apply it to the Industrial Revolution, consider this. Would the steam engine have been invented if not for the abundant coal that was available in the English Midlands? Would coal have been pressed into use as an energy resource if not for the inefficiency of early steam engines? So it was the fact that there was an abundant energy resource, coal, and that intersected with new technology, the steam engine. And that created the environment for an industrial revolution to take place. Now, that overly simplifies things, but it illustrates the requirements, technology and energy, that are needed for industrialization to occur. Now, combined with this formula of technology and energy are other geographic circumstances that we have discussed before: site and situation. Site factors, which are location factors related to the costs of factors of production inside the plant, such as, and these are the important ones, land, labor, and capital. Site factors are going to include things like labor costs and labor availability, land availability, accessibility of that land, the value of that land, taxes, energy costs, things like oil, electricity, or in the case of the Industrial Revolution, coal, local environmental regulations, local amenities, or say tax advantages. So from our previous example, coal is a site characteristic. But the value of coal dramatically increased with the invention of the steam engine. And that deals with productivity, which is the value of a particular product compared to the amount of labor needed to make it. The steam engine dramatically increased the value of coal, in part by reducing the amount of labor needed to acquire it. Coal was too bulky to transport, and infrastructure was too poor to transport it away from the coal mines, so early factories had to be located in rural areas. But with the invention of new transportation technology, like the steam-powered locomotives and then later automobiles, that affected the situation of industry during the Industrial Revolution. Now remember, situation is going to be location factors related to the transportation of materials to and from a factory. So situation factors include proximity to market, transportation options and costs, the benefits of businesses clustering together, which we call agglomeration effects, political policies, and other factors like proximity to schools for families of employees that affect a place in relationship to other places. But we must mention that all the site and situation characteristics may not change the location of a particular economic activity. Sometimes there are limitations from the physical environment. Consider primary sector activities. Many of them cannot occur anywhere. Oil reserves only occur in certain areas. So this may affect the location of oil refineries that process crude oil into things like petroleum. Now, the best way to combine all of these different factors of industrialization in terms of where a factory will locate is through location theory, which is a logical attempt to explain the locational pattern of an economic activity and the manner in which its producing areas are interrelated. So, the primary sector location theory is from our homeboy von Thunen. The secondary sector, or manufacturing location theory, comes from a man by the name of Alfred Weber. That is a name that you will need to know. Alfred Weber was a German economist, geographer, sociologist, and theoretician of culture, who came up with the least cost theory. Here's the definition. A model developed by Alfred Weber, according to which the location of manufacturing establishments is determined by the minimization of three critical expenses: labor, transportation, and agglomeration. So factory owners will look to minimize labor costs, minimize transportation costs, and will seek to minimize inefficiency through agglomeration. The most important of these costs is transportation, but more on that in a minute. The second cost that is considered is labor. Now, higher labor costs tend to reduce the margin of profit. So a factory might locate further from raw materials or the market if cheap labor compensates for the added transportation costs. The third cost that is addressed is agglomeration. Okay? That is a process of the clustering or concentrating of people or activities. The term often refers to manufacturing plants and businesses that benefit from close proximity because they shared skilled labor pools and technological and financial amenities. So again, this helps to reduce inefficiencies. That's what Weber was interested in. Industries can assist each other through shared talents, services, and facilities. For example, furniture companies will all need access to things like lumber, textiles, as well as ports and skilled employees. If they cluster in one location, as they have done in North Carolina, a region called the High Point region, all furniture manufacturers benefit because the government builds better infrastructure that they can all share, and business services like accountants and lawyers who specialize in things like contracts and trade will open offices to offer their services because the companies are there. So agglomeration can also attract workers who have industry-specific skills to a particular area. For furniture, it might be like carpentry. Agglomeration can make a location more attractive for a company, potentially overcoming higher transportation costs or labor costs. Again, the most important cost, according to Weber, was transportation costs. The cost of transportation is largely contingent on the weight of the goods being transported, but it is also based on the size or the bulk of the good. So the cost of shipping goods could also be more expensive if the goods have a short shelf life, like we talked about with fruits and vegetables in von Thunen's model. But the two terms that are often associated with Weber's least cost theory are bulk gaining and bulk reducing. A bulk gaining industry is an industry in which the final product weighs more or comprises a greater volume than the inputs. Make sure you know that it is also sometimes called weight gaining industries, a market-oriented industry, or market-dependent industry. So an industry where the final product weighs more or becomes larger in size will locate their factory closer to the market to try and keep transportation costs low. Then there are bulk reducing industries, which are industries in which the final product weighs less or comprises a lower volume than the inputs. Make sure you also know that it could sometimes be called a weight losing industry, a raw material oriented industry, or raw material dependent industry. An industry where the raw materials are heavier or larger, then the factory is going to locate near the raw materials because that's the most expensive part of the transportation process. These are examples of what is called the locational triangle. And this is the visual that we should associate with Weber's least cost theory. Now, with bulky commodities, friction of distance is especially important. If heavy raw materials are shipped thousands of miles to a factory, the friction of distance increases dramatically due to the huge increase in cost. Now, in the triangle of factors, the most important for lightweight consumer goods is a ready supply of low-cost labor. Being close to the raw materials is less of a concern, as shipping low-weight components is relatively inexpensive. So we then start to focus on some of the other costs that Weber was concerned with, especially labor. The whole goal of the least cost theory is to minimize production costs by balancing a variety of factors. That's a good way to remember the least cost theory is just the name itself. If you were a factory owner, where would you put your factory? It is the place where you would generate the greatest profit, right? You can maximize profits by minimizing expenses or by paying the least cost. Now, this is another way to visualize the locational triangle. It is based on the Verjean frame. The Verjean frame was developed by French mathematician Pierre Verjean, and it consisted of a series of weights attached to pulleys that together would find a point of equilibrium. Perhaps the best way to imagine this is by using an example. Imagine a product that requires 3 inputs. Input number 1 weighs 100 pounds. Input number 2 weighs 200 pounds. And input number 3 weighs 400 pounds. The finished product weighs 300 pounds. According to the Verjean frame, it would find equilibrium where input 1 must travel the farthest to the plant and where input 3, the heaviest, would travel the shortest distance. But the reality of solving Weber's location model often implies stages. The first stage would be finding the least transportation cost, which is what we see here. But then a factory owner would adjust this location to consider things like labor costs and agglomeration economies. Weber reasoned that industry will locate close to raw materials in order to lower transportation costs, but that the availability of labor, either particularly skilled or cheap, and then agglomeration of industry will pull the location of the factory in other directions. So make sure we remember that. Yes, transportation cost is first, but then labor costs affect it. The benefits of clustering together affect it. Now this slide is pretty simple, but let's make sure that we understand the basics. If the raw material is heavier than the finished product, it will locate closer to the raw material. All right, we call that bulk reducing. Raw material heavier, finished product lighter, factory located closer to the raw materials, to the heavier item. If the finished product is heavier than the raw materials, the factory will locate closer to the market. That's called bulk gaining. Raw materials are lighter, finished product heavier, factory will locate closer to the market. Essentially, the factory will locate nearest the heavier part of production. But then things get a little bit more complicated. There are other factors that influence the location of economic activities. We've already discussed that products that are heavy, like soft drink bottling, or bulky, like car or furniture construction, will locate closer to the market. Notice up at the top, all the greens have market orientation. They're oriented toward the market. But if the finished product is more perishable or time sensitive than the raw materials, as with baked goods or local newspapers, a location near the market is required. And if the product is more fragile than the raw materials, such as with glass items, the industry will be attracted to locations near the market. In each of these cases, the gain in weight or bulk or perishability or fragility, transportation costs of the finished product are much higher for the finished product than they are for the raw materials. But again, if the input parts are heavier and the finished product is lighter, as with copper smelting, or if they become less bulky, as with lumber products, the factories will locate closer to the raw materials. Notice down at the bottom, raw material orientation. And if the inputs are more perishable, as with fresh fruit before it is canned or frozen, then the factory will locate near the inputs, near that fresh fruit. And for the circumstances where there is a diminishing in weight or bulk, perishability or fragility, transportation costs of the input parts are higher, and the factory will locate closer to them as a result. All right, so time for some practice. This is going to be a fun little quiz, or as I like to call them, a fizz. Fun quiz, it's fizz, about manufacturing and whether or not certain activities are bulk gaining or bulk reducing. Will they locate closer to the market, or will they locate closer to the inputs, the raw materials? In your notes, please write down your predictions, and tomorrow we will discuss them in class and you'll have an opportunity to correct your answers. But make sure you write down some guesses. So let's start with some of these. Let's start with automobile manufacturing. What do you think? Bulk gaining, bulk reducing. What's your prediction? Our next one is going to be a lumber mill. Bulk gaining, bulk reducing. Closer to the market, closer to the raw materials. Next up, soft drinks. Closer to the market, closer to the inputs. Now, this one I want to make a special note is kind of an interesting example because the heaviest component in soft drink bottling, really in any kind of beverage, is water. That's the heaviest input, is water. And since water is widely available, many companies try to add it as close to the market as possible, rather than to pay to ship the weight of the water. So for example, soft drinks are often sold to restaurants as thick syrup, and then they hook it up to the water and add carbonated water at the restaurant. Kind of an interesting note. Our next example is ethanol. That's what you see happening here. This is an ethanol plant. What's your prediction? Bulk gaining, bulk reducing. Now, ethanol, just so we know what it is, uses corn that is then converted into an additive in gasoline. But as an added side note, the least cost theory showed up on the AP exam by examining ethanol production. So we have seen this as an example. So the map you see here looks at existing and planned ethanol plants in and around the Corn Belt. Does that influence your prediction? We'll see tomorrow. Our next example is any kind of smelting. Nickel smelting, the smelting of iron ore, or, as is seen here, copper smelting. What do you think? Bulk gaining? Bulk reducing? Now, as a side note, copper ore is very, very heavy. But most of the ore is waste that is discarded during the refining process. Does that influence your prediction? Write it down. And our final example, potato chip packaging plant. What do we think? Bulk gaining, bulk reducing. And for this one, think of the inputs and then think of the finished product. Remember, it is about the transportation cost, not exclusively the weight. Is it more expensive to ship the inputs or the finished product? Bring those predictions to class and we'll discuss them. So thus far, we have discussed market-oriented and raw material-oriented industries. These are especially concerned with transportation costs. But there are other factors that influence the location of processing activities. Let's start with an example of energy-oriented or energy-dependent industries. As the name implies, these industries will locate near cheap energy. So even though the aluminum industry requires raw materials, such as minerals, the energy demands are so high that factories are built in close proximity to major sources of abundant, cheap energy. China and Canada are both major producers of aluminum, which in the production of aluminum consumes a huge amount of electricity to break the bond between aluminum and oxygen during that production process. But Iceland's production is rising due to their abundant and cheap geothermal energy. Then we also have labor-intensive industries, sometimes called labor-dependent industries, which are, on the other hand, focused on the costs of labor. Certain technologies, such as computers, cameras, watches, required very skilled laborers. So as a result, high-tech, labor-intensive industries will often locate close to major training institutions, such as colleges and universities. When Weber was writing, transportation costs accounted for upwards of 50% of the cost of a good. But today, transportation costs account for less than 5% of the cost of a good. So we need to discuss factors behind that change. And so the development of railroads and just road infrastructure has made shipping times and costs decline. This is part of space-time compression that we discussed all the way back in Chapter 1. But in addition to that, we've seen the clustering of transportation infrastructure into what we call break of bulk points, which are a location where transfer is possible from one mode of transportation to another. This has made transportation systems more efficient, thereby reducing transportation costs. So let's look at a couple examples. Again, Break of bulk points are where goods can be transferred from one mode of transportation, like ships, to another, like trucks. So when the factory is situated at a break of bulk point, it makes transportation more efficient, thereby reducing transportation costs, which again is what Weber's least cost theory is so concerned with. Now, Los Angeles is a really great example of a break of bulk point. It is the busiest port in the United States, and containers can quickly be transferred from massive container ships to individual trucks and trains that are then shipped inland using the already established infrastructure present there. Before containers, a ship would arrive at port with various odd-sized crates and boxes. Hundreds of longshoremen would flock to the dock to unload the goods by hand. But today, the current volume of resources and goods that are shipped around the world daily could not be supported without the invention of the container system, sometimes called containerization, whereby goods are packed into standard-sized containers that are then picked up by special mechanized cranes from a container ship at a break of bulk point, which, it should be noted, is sometimes called an intermodal connection. Break of bulk point, sometimes called intermodal connection. And so they pick up those containers and place them on the back of a semi-truck, on a barge, or a railroad car. This innovation of containerization lowered costs and increased flexibility, and it permitted many manufacturers to pay less attention to transportation costs in determining where to build their factory. With containerization, ports now have relatively few employees who operate these high-tech cranes, moving containers from ship to dock or dock to ship with precision. And this is just another example of labor-intensive work, loading and unloading a ship, being replaced by capital-intensive inventions. So to finish up tonight, let's sum up what Alfred Weber's location theory has left us with. As transportation systems have improved, the model, the least cost theory, is not as useful for most products, except for those that rely on really heavy raw materials. But with networks of global cities, container ships that crisscross oceans in regular patterns, and flexible production, which we'll discuss next lecture, choosing an industrial location where to site a factory depends on a number of things. Things like, as Weber predicted, transportation costs, but also labor costs, and things that weren't factored into the least cost theory, like regulatory constraints, the expertise of workers, as well as access to energy. In future lectures, we're going to examine the global nature of industry. Have a good evening, everyone. I'll see you back in class.